Hello, all my students. Welcome to my YouTube video. This is Dr. Song. I'd like to start our quantitative research method course for the week 4. So in this week, we will study about the distributions data, especially about the normality, how you can obtain the normality of your data. So that will be our objective. And then I'd like to share these resources. I conceived my course based on the 3 courses here. So these are the references. And then learning objectives for today will be the normal distribution. What does that mean? The shape and then dispersion. That is about the standard deviation. And then positively and then negatively skewed distribution. That is also related to the standard deviation and then the kurtosis. That is a standard deviation and then a skewness. Skewness and the kurtosis coefficient. So how you will decide that is not a normal distribution based on the coefficient of the skewness and the kurtosis. So we will do basically about these 3 things for today. That is our learning objectives. So the introduction of the shape of distribution. So that is a kind of a normal curve. That is very important in the statistic. Why? Because we always use the sample. So the sample for the population. So when that is a normal curve, the sample, that means that we can consider the standard deviation is equal to the population, the standard deviation of the population. So that's why normal curve is very important. And also the dependent variable should be the normally distributed when you do the inferential statistics like many analysis. That is a parametric test that require the assumption the dependent variable should be the normally distributed. That's why it's important to have the normal distribution. And then mean score it will be used to examine the relationship between the dependent and the independent variables. So for the mean score is meaningful, you should have the normal distribution. If not, that is a skewness. Like for instance, that doesn't reflect the quite right number to consider the sample is equivalent of the population. That's why we need the normal distribution. So that is all belongs to the descriptive statistics. So when you obtain the descriptive statistics, this is the fundamental process. You should obtain those things. First, the shape, dispersion that is related to the standard deviation, how your data is distributed in the normal curve or not. Deviance means that is a z-score. So from the mean here, how much the individual scores are far away from the mean score. That is talking about the deviance. So we start with the shape. So when you have this shape, that is the mean score. And then from the mean score, the dispersion is by that way, is like a bell curve that we consider the normal distribution. And you can find this curve when you run the diagram, like a histogram, you can find that if this continuous variable is distributed normally. So that is a normal curve. And the normal distribution known as a normal curve and then Gaussian distribution, most widely used distribution in statistics. So as I said to you, to consider your sample equivalent to the almost equivalent to the population, you need the normality. Describe how continuous data are distributed around the mean. The characteristics are follows. Only one mode of the central tendency. So it's only the one mode that is like the mean score. There is only one. And then symmetrical. So there is a mirror image of the 50% in the left with 50% right of their shape. And then all measures of the central tendency are equal. That means that you have the mode, and then also you have the mean, and then you have the median. All these are in the same score, and that you can consider that is a normal distribution. So the mode means that most repeated score. Mean is the average score, and then median is the middle score. So all of them, they are in the same line. That means the normal distribution, and they are continuous variable. Most scores fall close to the mean, and a few scores fall closer to the tails. So the tails are here. So here they are less scores, and then they are more scores close to the mean. The standard normal distribution is asymptotic to the x-axis, farther away from the mean. So it's farther from the x-axis. And then the closer they get to the x-axis, but they never touch the x-axis. Yeah, so that is, of course, that is like a common sense. So the bell curve will be the far away from the x, and then they will never touch the x. And then what influences the normality? Skewness. Of course, this is one of the most influential factor, skewness. So when the distribution of the continuous does not have the standard normal shape, this means that their mean and median mode are not equal. Yeah, so their mean and the median and the mode are not equal, and the most scores are not closer to the center. This indicates the skewed distribution. So you can see what that means. So you can see that there's a mean here, but the many scores are they are higher than in the left part, not in the mean. So your median and the mean, they are not same position. In that case, you can say that this is positively skewed. Why? Because most of your scores are in the left, in the minus side. So in this case, you will say that they're positively skewed. And by the way, when you have the more scores in the right part, so positive part, and then the less minus part will be less, and you can say that that is negatively skewed. So you will consider that how is the direction. When it go to the direction to the positive way, you will say positively skewed, and then when the direction is going to the left, minus, and then you will say the negatively skewed. And then you will see that in that case, the majority of scores are in the minus part from the mean, and then the majority of scores are a positive part from the mean. So that is the interpretation. And then the kurtosis, that is about the height of the your bell curve, how much they are high. So that is a kurtosis. So you can see that when they are very low and they are like a flat, you say the prekurtic. And then when they are very high and then they are very close to the your mean score, that is a leptokurtic. So anyway, either or the other way, they are not a normal distribution. They should not be too much high. They should not be too much low. So kurtosis, that is related to standard deviation, the deviance, and the variability. So the between the 0, 0.5, 0.5, and then yeah, I will write here is a 0.5. Yeah, you will consider that is a 0.5 minus 0.5 or 1.5 minus 1.5. That is a moderate kurtosis. So that is not very high, not very much flat. So that is fine. We will consider that that is a kurtosis is a normal distribution. Skewness also between 0.5, sorry about that, and then minus 0.5, and then that is a minus plus minus 1.5. That also moderately skewed. So we will consider that is the range of the normal distribution. But if they are the outside of this indication, you will consider that that is a flat or high. So the platykurtic or the leptokurtic, you will say that. And the skewness also the positively skewed or the negatively skewed. So you will consider like this way. And the evaluation of the skewness and kurtosis, this is very important. That is by SPSS you can do, but also you can calculate. The very first thing you can calculate is that Pearson's skewness coefficient, that is a PSK. How you call that? How you obtain that? Mean minus median. So like here, is a mean score is here, median is here. Mean minus median, and then divide by the standard deviation. Yeah. So be careful about that because the calculation is a bit different. PSK, Pearson Skewness Kurtosis, you can say the mean minus median and then divide by the standard deviation. If this coefficient is greater than plus minus 0.2, you will consider that as severely skewed. If that is that coefficient is a zero indicates that normal curve, and then greater than plus minus 1 is significantly skewed. So you will consider that this coefficient is between plus minus 0.2. So you will consider that. Okay, and then here you can see that Another way to obtain the skewness and the kurtosis, this is the most frequently used. So maybe you will stick to this way, how you will calculate. So you can see the statistic of the skewness and then kurtosis, and then you will need the standard deviation, no, standard deviation error. You will need this number. So how you calculate that? You will see that the Fisher's skewness that is here is a minus 1.253, and then you will divide by the standard error of the skewness. So you will obtain that minus 7.789. So this is the outside of the plus minus 1.96. 1.96 means that is 95% of the your distribution. So that is outside of the 95%. That means that I will show you what it means. When you see the bell curve like that, here let's say that this is the plus 1.96 and this is a minus 1.96. So that skewness shows that this is the outside of this range. So that means that your data score is outside of 95%. That means that you will consider that that is very much skewed. So when there is a minus, that means that it's negatively skewed. So there are a lot of the points, the individual scores are in the positive part. And then also that the kurtosis, you can see that is here is a 2.184 divided by the standard error, 0.331. So you can see here, yeah, that is a formula. And then you obtain the 6.598. So this is a very leptokurtic. So that is outside of the plus minus 196. That means that it's 95% outside of 95%. So that is a very leptokurtic. So it's so the kurtosis was not a normal score, normally distributed. Yeah, so this is the for today. And then we will see the next time about the normality test. That is about the KS test. I will show you how you can obtain by the SPSS. So that is for today. And then you will know now how you can calculate the skewness and the kurtosis. That indicates your normality or not. So that is the for today. Thank you so much for listening to my YouTube video. And then if you have need a comment, if you need have some questions, you can leave the comments also. Thank you so much. See you next time.